Welcome everyone. Today we're going to look at example 1 and 2 from lesson 5 in module 1. We already did the beginning part of lesson 5 in class. We're going to write down starting just above example 1. It's important to note that the characteristics of graphs of proportional relationships are that the points appear in a straight line when we graph the points on the table, and that the line goes through the origin. Now we already know that a proportional relationship has the values of the ratio the same, but this is another way to see if a relationship is proportional. Let's take a look at example 1. In example 1, we're going to plot the points that go with the candy bar sold to the money received. The first point we're going to plot is 2, 3. We went over 2 units in the x direction, this is the number of candy bars sold, and 3 units in the y direction, the money received. So this person sold 2 candy bars and received $3. The next point is 4, 5. The third point is 8 candy bars for $9. And the fourth point is 12 candy bars for $12. Now it looks like these points are a straight line, and they could be pretty close to a straight line, but they certainly don't go through the origin. If I were to graph a line through them, you could see that they're a little bit off here in this point, and that this line definitely doesn't go through the origin. So this relationship is not proportional. If I looked at the value of each ratio, I could see that for $3 and I sold 2 candy bars, the value of the ratio was $1.50. But then for 4 candy bars sold for $5, it's not the same. It's still not the same for the third entry, and definitely not the same for the last entry. So I could say that the relationship between candy bars sold and the money received is not proportional because the points do not lie on a straight line and the line does not go through the origin. Now, I looked at this 2 different ways. I looked at it with the value of the ratio and with the graph. Either one of them is enough to say whether the relationship is proportional or not. You don't have to do both. Let's take a look at example 2. In example 2, we're going to graph the points from this table, and we're going to describe how it is the same and how it is different from the previous graph. Here's the first point, 0, 6. Well, I can already tell that this relationship is not going to be proportional because it doesn't go through the origin, which is 0, 0. Here are the next points. They look to be like they're in a straight line. Now this graph, it's important to note, the horizontal lines are every 2 units. So when I graphed 3, 9, I had to graph in between 8 and 10. And when I graphed 9, 15, I had to graph in between 14 and 16. If I draw a line through these points, it's straight. All the points are on that line. But it doesn't go through the origin. It doesn't go through the point 0, 0. So this relationship is also not proportional. If I look at its similarities with example 1, the line doesn't go through the origin in either example. What's different about this one is that the points are all on the line, but it's still not proportional. If I were to find the value of the ratio, the first one, 6 divided by 0, I couldn't even do. Right now, we don't have an answer for that. If I do 9 divided by 3, the second one, that answer is 3. If I do 12 divided by 6, that value is 2. 15 divided by 9 is somewhere around 1 1/3. And 18 divided by 12 is 1 1/2. So you can see the values of my ratio wouldn't be the same if I found them. So this is definitely not a proportional relationship. Okay, this was a pretty short video today. Make sure your notes are all filled out and then bring them to class for homework.